There was a quite long-winded title for this talk. I sort of condensed it down to Climate, Geoengineering, Dr. Strangelove and Dr. Salk. I'm sure you all know straight away who Dr. Strangelove is or was. He was the fictitious scientist played by Peter Sellers in the film of the same name, and who seemed to be bent on global destruction. Thank you. Some people today are less familiar with Dr. Salk. He was in fact the inventor of the polio vaccine. So what I'm trying to suggest here is that there's possibly a way of thinking about geoengineering, as some people do, as the thing that will save humanity from catastrophe, versus one which says that basically we are bent on inevitable self-destruction. So what am I talking about, climate geoengineering? Many of you know, but for some of you are probably not familiar with the field, so I'll briefly run through what it is and what the principal technologies are that are involved. It was defined in the 2009 report of the Royal Society Working Group as the deliberate large-scale manipulation of the planetary environment to counteract anthropogenic climate change. I want to make two key points straight off. Firstly, we're talking about what social scientists think of or describe as technological imaginaries. That's a horrible piece of jargon. But what it basically means is we don't actually have technologies yet. What we have is ideas. We have bits of kit that could be configured as part of a technological system to achieve the large-scale manipulation of the planetary environment, but we don't as yet have anything that resembles a technological system. And that implies things like, for example, the regulatory framework, the financing structure and so on that will go together, the imagined society in which the technology would be embedded. And the second thing I want to emphasize right up front is when we use the term climate geoengineering, we're generally speaking referring to an extraordinarily heterogeneous set of technological practices, many of which actually have nothing in common with each other. It's a bit like nanotechnology. When nanotechnology first came on the scene, this was a new category of activity, stabilized around the term nanotechnology. But what did it include? It included things like various forms of microbiology, electronic miniaturization, molecular engineering, and so on and so forth, things which actually, as technical practices, have very little in common with each other, but were stabilized around this idea of what happens when you start to operate on the very small scale. So we're talking about things that are very early stage, still at the imaginary stage in many senses, and we're talking about a wide variety of things. So what are the kinds of things that one might do, and how might you do them? Well, there's basically two things you can do to manipulate the planet in this way. One is to reflect some of the sun's energy back away from the Earth, what we've been calling thus far solar radiation management. Some people like to call it simply sunshine management or something like that to simplify it a little bit. The other thing you can do is you can remove carbon dioxide, in principle other greenhouse gases, but at the moment nobody's seriously suggesting anything for other greenhouse gases. Remove carbon dioxide from the ambient air, or what we call carbon dioxide removal. This is now actually becoming known by another term, NETs, negative emissions technologies. So you may hear that term as well. So there's two things you can do. There's also two ways in which you can do both of these two things. One is that you can actually do traditional engineering. You can make black boxes that do things for you. So you could take carbon dioxide out of the atmosphere by building arrays of machines like this through which you pass ambient air, subtract the carbon dioxide and sequester it, for example, in spent oil and gas wells or in other forms of sequestration. We know how to take carbon dioxide out of the ambient air. We do it in submarines already today. It's just hideously expensive to do it that way with what's so-called amine technology. And people are now looking at various less expensive ways of separating the carbon dioxide from the ambient air. Similarly, you could put mirrors in space, possibly at the Lagrange point between the Earth and the Sun, or some kind of orbital mirror. Probably not actually one big one, as in this artist's impression. It'd be more likely to be a number of much smaller devices that cumulatively would reflect a certain amount of sunlight back. This, by the way, is the least discussed option because of the obvious factor that the lifting capability to get lots of kit into space is going to be quite constraining economically. We've already lost a lot of the capacity for lifting heavy payloads into space that we had when, for example, we had the shuttle program. But we can also achieve both reflecting sun's energy away and taking carbon out of the atmosphere by directly intervening with, if you like, enhancing existing Earth system processes. If you don't like them, it's tinkering with existing Earth systems processes. So, for example, you could take carbon dioxide out of the ambient air, some people are arguing, by enriching the oceans in certain places with iron. The idea here is that there are certain places where plankton growth in the oceans is constrained by the availability of iron. If you put additional iron into the oceans, you will get plankton bloom. Fish will come along and chomp up the plankton, and the fish poop sinks to the bottom of the ocean, and hey presto, you sequester some carbon. In the initial experiments done by a joint Indian and German team, by the way, they did manage to get the plankton bloom to happen very nicely. Unfortunately, though, the plankton got eaten by jellyfish that have like floaty poop, and the carbon went back up into the atmosphere instead of sinking to the bottom. That are just indicative of some of the kinds of obstacles that have to be overcome for this kind of procedure. The other way I've illustrated here that one could reflect sunlight by enhancing natural processes would be by adding sulfate aerosols to the stratosphere. Why do I call that a natural process? It doesn't sound very natural. Well, volcanoes do this periodically. To a very rough approximation, and I'm doing huge violence here to the science at the precise level, to a very rough approximation, when Mount Pinatubo erupted a few years ago, there was about a 2-degree global average temperature attenuation that lasted for about 2 years until that sulfur precipitated out of the atmosphere. So basically, the idea is there's two kinds of things you can do. There's two ways you can do both of these things. Now, these ideas about intervening in the climate system in this way are not entirely novel. They date back at least to the 19th century. There was a gentleman by the name of James Pollard Espy, known to his contemporaries as the Storm King, who in the 1840s suggested to the US federal government that it buy up woodlots across the United States and set fire to these to create very hot conflagrations, the idea being that this would cause convection currents, bringing pulling air in from the surrounding area, which would then cause precipitation. So the idea was you would make rain by creating these big convection currents. Interestingly enough, that idea was opposed by people in the southern states who were already concerned about emerging tensions that eventually erupted in the American Civil War. And they were concerned about the potential militarization, as they saw, of that technology. And that remains a concern that some people have today about geoengineering. I think it's a largely misplaced one, personally. I think there are much easier ways of causing severe damage to your enemies than trying to mess around with weather systems. But that's just a personal opinion. The rain follows the plough. I've deliberately used the American spelling of plough here because this was a dominant theme in the settlement of the Great Plains in the United States. The idea here was that actually as you ploughed the plains, you would release soil moisture, which would then cause the hydrological cycle to speed up, and that the ploughing itself would enhance the availability of rainfall for agriculture on the Great Plains. It was also, by the way, an idea that was adopted in Australia around the same time. Some of you may already be familiar with the cloud seeding efforts that were attempted particularly in the United States from the 1940s onwards. There is today, as we understand it, quite a lot of cloud seeding that goes on in China. But unfortunately, as almost the entire literature is in Mandarin, it's not readily available to us to evaluate either the true extent or the effectiveness of those activities. Go back to 1965, the first ever report to the US President on climate change from the President's Science Advisory Committee only considered what today we would call geoengineering options. There was nothing in that report about what today we would recognise as greenhouse gas emissions mitigation or adaptation. It was entirely about big interventions of the sort that we're talking about. So given this history, why are we now thinking about geoengineering? There's lots of reasons that people have put forward. The one that was foremost when it was initially revived by Paul Crutzen in an article, well, a series of articles in Science magazine and in Climatic Change, the journal, was that basically we've reached an impasse in negotiations to put in place an effective greenhouse gas emissions mitigation regime worldwide, and this was seen as a way of cutting through that Gordian knot of diplomatic stalemate because of the imagined absence of incumbents. One of the reasons why those negotiations have been seen to be difficult is that we've got very strong vested interests in the fossil fuel industry, in internal combustion technologies of particular countries that, of course, see their development pathways very much dependent upon the exploitation of fossil fuels, not least of which is, of course, China and India. There's also other motivations that people have put forward. They've suggested that if indeed there are certain tipping points with climate change where concentrations reach a certain point, that we might have some runaway greenhouse effect, melting of the polar ice caps, or the release of methane clathrates from tundra and so forth, that we might use these technologies, particularly the solar radiation management technology, as a way of shaving the peak off the temperature rise, while we actually then deal with the problem more fundamentally through emissions mitigations. There's another reason, which is that actually as we reduce our greenhouse gas emissions and as we clean up the atmosphere more generally through things like controls on the use of dirty diesel in shipping, international shipping, that we're actually taking sulfate aerosols that currently are in the atmosphere, reflecting some of the sun's energy away, out of the atmosphere, and that those have been masking some warming that will then catch up with us as we remove that sunshade effect of those for other reasons. And therefore, the idea of deliberately putting some sulfate aerosols back in at the stratospheric level to maintain that masking effect has been proposed as another motivation. Tackling non-point source emissions. Something like 60% of our carbon emissions actually don't come from sources like power stations that are easy to control, and it's been suggested that actually removing carbon dioxide from the atmosphere is a way of dealing with these. Perhaps the most dramatic example is the jet engine. If you think about it for a moment, you can't capture the carbon coming out of the back end of a jet engine and still have a jet engine, because if you did, you wouldn't have any propulsion. It would be completely pointless. So perhaps carbon removal from the ambient air is a way of dealing with airplane emissions and other non-point sources. Another reason which you don't find written down very often, but I've detected frequently in conversations, or at least not infrequently in conversations with people, is that they see these technologies as being big and scary, and they think that if we advocate doing them or investigating them, this will actually scare politicians and the populace into trying much harder at conventional mitigation in order to avoid going down the pathway of these big, scary interventions. There are other reasons, of course. There's commercial potential for new industries and services. There is doubtless the possibility of developing a whole industry of carbon removal, if indeed you can find a way to establish, for example, a refundable carbon price or a refundable tax or something on carbon that would actually yield a revenue stream. But generally speaking, almost everybody you talk to who's thinking seriously about geoengineering emphasizes that these technologies could only be a complement to, not a substitute for, conventional greenhouse gas emissions mitigation and increasingly recognizing the inevitability of adaptation. And we have seen, more recently still, recognition of the impossibility of meeting our temperature stabilization goals through mitigation alone. I'm going to go back here to 2000. This is the time when this particular set of emissions and temperature scenarios were generated by the IPCC, the so-called stress scenarios. You can see here, these are basically the levels of temperature rise that are projected to occur dependent upon different sets of assumptions about economic development and technology over the course of the next century. And as you can see, the range of potential temperature rises is between somewhere about 1 degree and somewhere just shy of 6 degrees Celsius. And the bad news, folks, is that we are currently on the top line of this trajectory. Global emissions are increasing at about 3.4% per annum at the current moment. And so we would seem to be headed on that basis to 6 degrees. Now, that's the good news, because what the IPCC assumed at the time, in 2000, in making these scenarios, was that a 100-year-long trend of declining energy intensity per unit of global GDP and declining carbon intensity per unit of GDP would be maintained. In other words, for about 100 years, we've been using less energy and less carbon per pound's worth of stuff or pound's worth of wealth that we've generated. 5 years ago, that flipped, and it's rising. At the time, my colleagues on the IPCC said this is just a blip, this is an anomaly. It's now been recognised that it's not an anomaly, it is in fact India and China, and it's their development trajectory. So if we then take away the assumed benefits over the next 100 years of that spontaneous reduction of energy and carbon intensity, Roger Pilkey has suggested we're looking at something like this. In other words, under the IPCC scenarios, we're expecting the cumulative emissions over the next 100 years to be the red and green areas, and we would need to reduce just the red area. But if we factor in rising carbon and energy intensity, you can see that the amount of avoided emissions over the next 100 years may be as much as 3 times as much as the IPCC was then calculating. Fortunately, people are now cottoning onto this. The truth is sinking in. This is a quote, it's a slightly condensed quote from 2011 emissions report of the IPCC, saying a 50% probability of limiting warming in the next century to 2 degrees Celsius requires large amounts of negative emissions. And that's been backed up by UNEP in its 2012 report, saying that to achieve negative emissions implies a need to apply new and often unproven technologies. The problem with with relying on the negative emissions technology is, of course, can you scale that up quickly enough to have an effect by, say, mid-century, let alone the end of the century? You're talking about creating a massive infrastructure here. If you're talking about, say, enhanced weathering, which is putting minerals on the ground in order to absorb carbon dioxide, which is one of the methods being proposed, you would have to create something on the scale of the global cement industry to do that. If you're talking about doing the carbon dioxide removal machines, you have to create something on the scale of the global electric utility industry in order to do that. And the question is, can we actually do that in time? Solar radiation management, particularly the sulfate particle injection, there are other solar radiation management technologies, but the sulfate particle injection promises to act much more quickly and to have high leverage. But for reasons that I'll expand upon, I think that's much more problematic from a social, diplomatic, and indeed ethical point of view. So we're confronted with what I have called the geoengineering paradox. My philosopher friends have chided me for this. I should have called it the geoengineering dilemma. Apparently it's not a paradox, it's a dilemma, but it's already in print, so I'm stuck with it. Is that the technically easiest and fast-acting technologies, which would be that sulfate particle injection, may be the most difficult to govern. I cannot conceive of us doing that without either a global international agreement or a massive diplomatic furore if some country were to go it alone. On the other hand, the easiest ones to govern, which are the carbon dioxide removal technologies, which it would seem you could do under existing national planning and environmental regulations, may be the most distance from being effective, because by the time you scale it up, and then, of course, you have the problem that you have with any other emissions mitigation, that it takes decades for cuts in emissions or removal of carbon from the atmosphere to actually work through the climate system to affect temperatures. What are the concerns that are associated with geoengineering technologies? There's a whole bunch of them. One is some of these are about concerns about can we do it, and some of these are about concerns that arise from what would happen if we did do it. Among those about can we do it is technical feasibility. As I say, we've got bits of kit that work on the lab bench. David Keith has a machine in Calgary which is sucking carbon out the atmosphere, and he's using the carbon that's been withdrawn from the atmosphere to synthesize fuels, liquid fuels. But it's not clear yet whether you can actually scale this kind of technology up. The same thing with any kind of solar radiation management. There's the whole question of timing, as I've already mentioned, particularly if you're looking at the carbon dioxide removal technologies, you're going to have a long time lag before they kick in. That may be different with the solar radiation management technologies. You've got the question of costs and financing. If you look at the cost estimates for these technologies, they will tell you that relatively the solar radiation management through sulfate particle injection looks fairly cheap. That's probably true, relatively. Other than that, basically, all of the cost estimates are, I think the polite way to put it is highly dependent upon the input assumptions. They're highly sensitive to the input assumptions. In other words, if you want to make it look expensive, you can. If you want to make it look cheap, you can. It depends on what you assume about the variables going in. There's a lot of concern, obviously, about unintended consequences. If you were to cool the atmosphere by putting, say, sulfate particles into the stratosphere, you're not necessarily just going to shift the climate system. Well, you're not going to shift the climate system back into what it was before it warmed up. It's a complex dynamic system. It will go into yet another state. You might find that there's disruptions. One model, at least, has suggested severe disruption of the Asian monsoon. Other models have said that that's not likely to happen. But clearly, there is lots of room for concern about unintended consequences. Others have raised the so-called moral hazard problem. This is an insurance term for those of you who are not familiar with it. It basically means that if you allow people to insure against unwanted events, they're more likely to carry on with hazardous behavior. So people continue to live on floodplains in the United States because the US federal government provides federal flood insurance and bails them out every time they get flooded. So they keep rebuilding and rebuilding in the same hazardous spot. The idea here is the moral hazard that's envisaged is that if we start talking about get out of jail cards, as some people have characterized geoengineering negatively, that in fact that this might attenuate people's efforts to do conventional mitigation. I think actually as the message sinks in that we're simply not going to be able to meet 2.5 degree targets in the course of the next century without taking carbon out of the atmosphere, I think that will be a less valid concern. Another concern is the slippery slope argument. It's related to the moral hazard, not quite the same. It says that basically this is an argument where people say humanity has never given up a technology or has never failed to develop a technology that it's invented. This is, of course, arrant nonsense. The world is littered with technologies that were never developed. Of course, we don't think about them precisely because they were the ones that were never developed. They're not visible to us. But there are lots of instances where people have invented things that we have not subsequently gone on to implement. There are concerns, however, about technical and socioeconomic lock-in. One form of technical lock-in with solar radiation management is if you're relying on your stratospheric sunscreen to keep the Earth cool, and you keep pumping carbon dioxide into the atmosphere, and then you discover, oh, that one model was right, we are screwing up the Asian monsoon, better switch it off. Well, the good news is it only takes 2 years for that sulfur to clear out of the atmosphere. The bad news is that as it clears out, you'll get a very rapid temperature spike. This is the so-called termination effect with solar radiation management. So that's an example of technical lock-in. Once you start doing it, you are committed for probably the long term to continue doing it. An example of economic lock-in, think about those carbon-sucking machines. In principle, of course, if there's a negative consequence from removing carbon from the atmosphere, I can't think what one would be, but if there were one, in principle, you could just go and flip the switch and switch them off, right? Except just think of the massive investment that you have had to develop in order to finance that industry, to be able to develop those machines. You've created a vested socio-economic interest in keeping that technology running, which might be equally difficult to move away from. There are issues of public acceptability of these technologies. Clearly, I've already mentioned the fact that some of them seem big and scary, and there's the whole question of governance and regulation. Who would decide on a global scale whether we would, as a planet, engage in solar radiation management, for example? How would we regulate the industry? How would we even regulate the research process? and ensure that research was conducted in a responsible manner, and not in the manner that some of you may have read about recently in Canada, where a rogue, I don't want to call him a scientist, but a rogue entrepreneur decided that it was a good idea to dump lots of iron into the ocean off the Canadian coast. We're really faced with something which is known to social scientists as the Collingridge Dilemma. Collingridge was a social scientist in the 1980s who was underappreciated in his time, which was a source of some hope for me. Underappreciated in his time. Sadly, he's dead now. But what he wrote about was saying that really with a new technology, you want to know at the front end of the technology what the issues are that you want to regulate downstream. So think about asbestos, for example. If we had known that asbestos, that seemed like a wonderful substance that saved countless lives through improved quality of brake pads and acting as a fire brake and so on, that it would have the negative consequences in terms of respiratory disease downstream. And then, of course, by the time you've found that out, the asbestos is everywhere, and it's hideously expensive and difficult to undo what you've done with that technology. So he said, ideally, you'd want to know upstream, but of course you can't, because in fact technologies seldom develop over time in the way that the originator of the technology envisaged that it's going to develop. And so he said that there was that this was a problem, but his was not a counsel of despair. He said the solution is where you have the choice, you should opt for flexibility. You don't always have a choice, but where you do, opt for flexibility. And he said signs of inflexibility in technology are capital intensiveness, long lead times from proposal to operation, hubristic claims, and so on. And I think we have to say that a lot of these do sound like characteristics of geoengineering techniques. What could be more hubristic than I can save the planet with a few tons of sulfur and a couple of aeroplanes, to put it like that. There is, of course, vociferous opposition that we've already heard to these technologies. Some of our favourite environmentalists have spoken out on the issue in their carefully measured ways. David Suzuki has said geoengineering is insane. David Attenborough famously quoted on the BBC saying it's, dare I say the word, fascist. And the Etc. Group, a Canadian-based NGO, has issued a report here, you can see, with the title Geopiracy. I'm not going to dwell on all of those particular critiques, carefully reasoned though they are, but I think they do raise some serious issues for us. And this is the compatibility of this kind of technology with democracy, and this is an emerging concern, particularly in science and technology studies. A number of recent papers addressing whether, in fact, particularly the sulfate aerosol injection technology is in fact compatible with democracy because of the implications of the technology. Now, this is probably a little bit of a side argument for people who are interested particularly in STS, but it does seem that this is curiously an essentialist concept of the imaginary of solar radiation management. What I mean by that is the technology doesn't really yet exist, and yet these people are defining the technology in a particular way. So they have already locked into a model of the way the technology is going to develop. Whereas, what I was trying to illustrate here is that there's in fact lots of ways in which potentially any of these technologies might develop. So it's curious in that respect, particularly as science and technology studies as an academic field, generally speaking, rejects essentialist formulations of technology. It's also intellectually parochial, I think, in the concept of democracy as being local, participatory, discursive mechanisms such as focus groups, consensus conferences, and so on and so forth. Our colleague Pak Hang Wong here is working on a paper at the current moment looking at what would it mean to talk about public engagement in decision-making about geoengineering from a point of view of Chinese culture and a more Confucian vision of what society is, the role of individual in society, and so forth. These papers also implicitly tend to compare the world with solar radiation management to an ideal democratic state which doesn't actually exist, and which has, in their way of thinking about it, effective mitigation already, and say, oh, we would be much better if we democratically did proper mitigation than do solar radiation management. But on the other hand, the default position isn't that world where we're effectively doing mitigation and where we have nice, touchy-feely, participatory democratic processes. But I think it's important, that, however, that this discussion is happening, because I think it does raise legitimate issues about consent, and I'm now going to get onto some of the ethics dimensions a bit more, and highlights the institutional arrangements that would necessarily be in place. So I'm going to talk about some specifically ethical dimensions. I should emphasize at the beginning, for the philosophers in the audience, although my undergraduate degree was in philosophy, I am not a philosopher. I'm a cultural anthropologist by training, and I'm thinking about ethics here as I encounter people making ethical arguments in a day-to-day way. It's a sociological and anthropological approach, rather than from the standpoint of analytic philosophy and trying to analyse, particularly, what would be the right thing to do. So some of the specifically ethical dimensions that we encounter in these discourses, one is the role of intentionality. And that comes in two ways. It has been, people have responded to this debate about geoengineering by saying, but we've been geoengineering the planet for millennia. You know, basically, as soon as we started deforesting large parts of the planet, we started geoengineering it. And we have actually, and therefore this isn't new, is part of the argument there. Intentionality, other people say, no, but the point is we didn't know we were doing it then. Now we know intentionally that we're thinking about intervening to change the way, the pattern of ecosystems and so on. And that makes a difference. So that's one way in which intentionality comes up. Another is in terms of actually some of the things that you might do, particularly in the research leading up to geoengineering, you might do exactly the same things for reasons that have nothing to do with geoengineering. So, for example, you might want to spray some aerosols into the atmosphere to understand simply how clouds form as an experiment. Now, if I'm a scientist and I'm interested in cloud formation, I want to spray a bit of sulfur into the atmosphere because it's nothing to do with geoengineering, Gov. Okay. On the other hand, if I want to do exactly that same thing because I'm trying to explore geoengineering technology, is that different? Is there an ethical difference between the two of those that means that we need to pay attention to the intentional act that's seen as part of a geoengineering experiment? Another area is the ethics of terraforming, the standing of non-human nature. There are those who say, actually, this dates back to people like Izzy Stone and the, that wasn't Izzy Stone, it was Izzy Stone's son, wasn't it? The sort of do trees have standing kind of arguments from the 1970s. What are the obligations that we owe to other species, to other, in some cases, even non-animate manifestations of nature? Is there something inherently unethical about interfering in those? Do trees and rocks and things have rights? And there are those who would try to make the argument that they do, and that we need to take that into account. But I'm going to focus more on three things. They're what I've called in the past the TLC factors. In this case, not tender loving care, but trust, liability, and consent, because I think that these are really important issues. And they're issues about which you find different groups of people in society have cleave fast to very different principles for dealing with them. So let's quickly just run through these. Trust. Now, trust encompasses both confidence in the technical competence of people, so it's basically, are the scientists competent? Do they really know what they think they know? And also the behavioural integrity of people who are making decisions. So if you like, both the science and the politics. And on the science side of things, you can say, can we ever know enough about Earth systems and complex technological trajectories to be sure that our interventions in geoengineering are, in fact, prudent interventions to make? That's on the technical competence side. Could we ever get sufficient technical competence? But there's also the fact that different institutions, different cultures, different groupings of people, constituencies, look to invest their trust in very different forms of authority to adjudicate technical competence and to act in the public interest. So we find that hierarchical organisations, bureaucratic organisations, hierarchical cultures tend to trust well-tried routines and rules. Basically, basically, if you think about it, hierarchies, bureaucracies, they work on rules and rule books and roles. And if you know, for example, the people who are responsible for inspecting shipping for safety, the US Coast Guard actually does this for all offshore pleasure boats and so on in the US. People have a very high level of confidence in them for doing that. They've been doing it for a very long time, and they've been seen to be doing a very good job of it for a very long time. The assumption is they've got the right rules, they've got the right routines, they know the right procedures, and provided all that's in place, we can be confident that the technology will proceed in a manner that is worthy of our trust. On the other hand, you find that competitive organisations, competitive social contexts, market contexts, tend to look for people with the right stuff. So you look for a Richard Branson to go out there and deal with the problem because he's an entrepreneur who's shown he's got the right stuff. You look for people whose personal track records, rather than their institutional or organisational ones, have been seen to perform well. But when you move to egalitarian or collectivist kinds of social contexts, that's very different. There you only trust public deliberative mechanisms. You want the town meeting. You want a referendum. Basically, you have to only make these decisions after extensive consultation. So you've got three very different ways of investing trust. Interesting enough, when we get to liability, we also find packaged alongside these different preferences for who pays if something goes wrong. How are we going to decide how to deal with something that goes wrong? I've thrown in here rules and codes. I mean, roles, as those of us who enjoyed the musical event recently, the John Rawls' Theory of Justice, the musical that was put on at Keble. It was the best night's theatre I've been to in a long time. Rawls suggested that, in fact, in order to have fair outcomes, decisions are best made under a veil of ignorance where you don't know who the winners and losers are going to be. It's a very different approach from Coase, who was an economist, and Coase said actually the best way to deal with these situations is to find out exactly who's going to win and lose by exactly how much, and then you make compensatory payments. Sounds great in principle, only actually we don't have a very good history worldwide of making compensatory payments to losers. Why would the powerful give resources willingly to the weak?
Where did Coase say that?
It goes back to the 1960s, I think.
Sorry,
okay.
Not my understanding of what Coase said.
I'll have to go back and check it out. But anyway, there are different ways of dealing with these things. Who pays even if all goes well? Is there a historic debt that the North owes to the South, whereby, for example, the North should pay all the costs of doing geoengineering because we are dealing with this legacy of past greenhouse gas emissions? Is there liability for unforeseen or even unforeseeable events? Question that Claire Hayward is currently working on here under the Oxford Geoengineering programme. And we find that different constituencies again favour different approaches. Hierarchies want to deal with the question of liability by distributing costs where they cause least disruption to the system, so-called deep pocket approaches. So the idea here is system maintenance, don't rock the boat. So those who can best afford to pay with the least disruption, that's where you go and make, those are the ones you make pay. Very different from competitive market contexts who want insurance mechanisms, market mechanisms, in order to spread losses. And again, very different from egalitarian collectivists who insist on strict liability, because that's the only way you're going to keep these bastards honest, is that if something goes wrong, you really make them pay for it. You see that, for example, coming out current moment in the public attitude towards BP in the United States with respect to the Gulf oil spill. And then finally, consent, and the whole issue with geoengineering, what kind of consent is required, from whom is consent required, do we in fact need a global treaty before we can engage in solar radiation management through sulfate particle injection, Some people have expressed concern that some countries might go it alone. It's even been suggested by one commentator that we might have a green finger phenomenon, not gold finger, but green finger, a wealthy individual who might try and do sulfate aerosol injection. I think that last is highly unlikely. If countries did not approve, we'd find ways of closing an individual down. But on the other hand, if China decided to do it and the rest of the world wasn't so keen, or the United States, I think less likely, there would be the issue there. So what kind of consent is required from whom? Do national governments meet the test of representing their citizens? If indeed the model that we have for citizen consent is a deliberative participatory one, and we then look to governments of countries which have different forms of authority that are not based on the will of the people in the way that we recognise it, would we recognise them as being able to provide consent on the part of their populations? Again, different constituencies favour different approaches. Hierarchies and bureaucracies basically are happy to work on the idea that if the institution is seen as legitimate, then the decisions, individual decisions, are accepted as legitimate, even though you might not like that particular decision. As a US taxpayer, I confront this every April because I have to file my US tax return. I have to accept that even though I don't want to pay my US taxes if I didn't have to, because I accept the legitimacy of the government to tax me, I therefore consent to pay my taxes. Competitive markets, on the other hand, are perfectly happy in market context to accept revealed preferences. And here it's, for example, if I had 3 levels of environmental protection that are differentiated only by their effectiveness and their cost. So the most expensive is the highest level of protection, the cheapest, the least level of protection. And I opt for the middle level. I may be said to be consenting to the higher level of risk that I incur by not buying the more expensive level of environmental protection. So basically, this is shopping is the new voting kind of idea. And then you find egalitarian kinds of social organisations insist on explicit consent. You have to ask people and they have to say yes or no. And this gives rise to a particular problem that these kinds of social and cultural settings have with intergenerational risk, because you can't go to future generations and ask them. And if I can't go and ask them and they can't say yes, then I cannot impose a risk on them. So you find you actually get negative discounting, refusal to discount on projects coming from those quarters, and in what some people would describe as a tyranny or a dictatorship of the future. So these are actually we can empirically find these different packages of trust liability consent in this way as we look into societies. And one of the problems that we're going to face is the fact that it's not that any of them are self-evidently right or wrong, and even if one were, they are the reality that they're distributed out there, and how do we resolve the conflicts among them in a democracy. I'm just going to quickly whip through something about governance architecture now. Bearing that in mind, the Royal Society concluded in its report that the acceptability of geoengineering is going to be determined as much by the social, legal and political issues as by scientific and technical factors, and was looking towards the next stage, which is not actually whether or not we implement these technologies, but whether we even do research on any scale that would lead to developing these technologies as viable options, something beyond the technological imaginaries that I've discussed to date. And a group of us got together, including Julian Savulescu, who's in the room, Tim Kruger, Catherine Redgewell, who's at UCL, but will be joining Oxford next year as the Chichley Professor of International Law, and Nick Pidgeon from Cardiff University, to think about what kind of governance architecture you would need, at least specifically for the next stage of research, but preferably even thinking out beyond that. We figured you need a few guiding principles that would establish the key ethical and governance concerns of the public, and that because of the heterogeneity of the technologies, you would then need more specific technology protocols that would be nested underneath those. So the principles had to be applicable to this highly heterogeneous range of technologies. We wanted to apply from research through to initial deployment. Felt it was important to recognise that there is a distinction between activities that cross international boundaries, and we also felt that if we could, that they should be principles that could at least be implemented in principle through existing national structures, particularly at the research stage, rather than trying to develop some new international treaty, because we know how good we are at developing international treaties on climate issues, don't we? And we would be decades, I mean, the opportunity would be been and gone by the time we got there. So we devised a set of 5 principles that we submitted to the UK Common Science and Technology Committee. And the 5 principles are here: geoengineering to be treated or regulated as a public good, public participation in decision-making or engagement in decision-making, full disclosure of engineering research and open publication of the results. That, by the way, was inspired very much by concerns that we had with the pharmaceutical industry's record of not publishing negative results of clinical trials. And we felt it was very important that all the information be out there in the public domain. Independent assessment of impacts of each stage of research, as well as the long-term impacts of the implementation of the technology, and that the governance arrangements needed to be very clear before any deployment was implemented. These, much to our surprise, we submitted these to the committee. The committee actually used these as a way of structuring a large part of its report to the UK government, and the UK government, in its official response, in fact, with some qualifications, endorsed the principles that we put forward. And I presented them in 2011 at the International Conference in Asilomar, which was a conference which was explicitly called to, in a sense, to borrow the robe of the Asilomar Conference on recombinant DNA, for those of you who know what that was. This was when basically the biologists got worried about maybe recombinant DNA is dangerous, and they met in Asilomar and called a temporary moratorium on the development of the technology. The Asilomar Conference did not call for a moratorium on geoengineering, the one that happened more recently, but did adopt very similar principles to these. The technology-specific research protocols, this idea basically is that these would be nested underneath those principles. This is to say, at each stage of research, you would have a stage gate process, whereby before you fund or before you engage on the next round of research, you would check that you are addressing the issues that we highlighted in the Oxford Principles. And the idea here is that you would enable to, by doing this, to enable both the people doing the research and the community in which the research was being performed to have a fairly high level of confidence that the issues that were being highlighted by the principles were being addressed. One of the technologies that was recently subject to a proposal for an experiment was the so-called SPICE project, this one illustrated here. The ultimate technology vision is you have a ship about the size of an aircraft carrier, a balloon about the size of Wembley Stadium on a 20-kilometre tether, and you're pumping the sulfate aerosol up a tube. Now, what the experimenters wanted to do was to build a miniature version of this 1 kilometre high on a Cambridge airfield and just pump water up the hose. And they wanted just to investigate some of the engineering difficulties involved in balloons with hoses attached and tethers and this kind of thing. The funding agencies, the research councils, insisted that there be a stage gate review to see whether or not they, both to review the technical aspects of the project and also to ensure that adequate public engagement had been carried out in the area where the experiment was going to be conducted. And before they were going to the next. Now, in fact, what then happened was that it was found initially that they hadn't done enough public engagement. They were sent back to do some more. Unfortunately, before that process could be continued, it was then discovered there were some intellectual property issues that hadn't been previously surfaced among the researchers, which led to the entire experiment being terminated. But I think in principle it does show that this idea of phasing research and setting particular standards for what you expect at each stage is quite plausible. So here are my concluding thoughts. I don't think that we're dealing with Dr. Strangelove here. I've got enough grey hair, having been through successive decades of new technology controversies, from nuclear energy, GM foods, nanotechnology, you name it. At each stage, I have encountered scientific advocates who were perhaps in the Dr. Strangelove mode, those who said this technology will save humanity, we should go full steam ahead, damn torpedoes. Those people who are opposing us are anti-science, they're anti-technology, they're Luddites, etc. I've heard none of that in the discourses around geoengineering. What I've encountered is a scientific and engineering community that is deeply ambivalent and highly reticent in following even down the research paths with these technologies. I think that's a phase change from our past experiences. I think we do need research and development to fully characterize these technologies so that we know actually which of them do, if any, have potential to be implementable and effective, which we should avoid with the proverbial barge pole, and really have a much more informed discussion and debate about them once we know what they really imply, rather than just be dealing at this level of imaginaries. I think careful governance is required for the entire process of research through implementation. I think both any of the unencapsulated techniques which involve sticking stuff out into the Earth system to cause a change, rather than the black box techniques, require particular attention. And they're not just the solar radiation management methods. Any form of ocean fertilization, iron fertilization, or whatever, I think also requires particular attention. I think we should be very cautious of any hubristic claims that are made for the technologies. We need to recognise the ethics are going to be highly contested. Ultimately, I would argue the technologies will not be employed. This is my personal view. They won't be employed unless they're widely deemed to be safe, affordable and effective. Now, all three are weasel words, I know. They are subject to wide interpretation, but I think unless there is a consensus generally that those three conditions are met, we won't deploy these technologies at all. And if they are, I think then we will be looking back on the debates that we have about them and wonder really what all the fuss was about, because they'll just become part of the portfolio of things that we use to respond to climate change alongside conventional mitigation and adaptation.
Thanks very much, Steve. I think I meant to say some remarks for 10 minutes, but I'll just say a couple of things and then we'll have open questions. So I think it's quite important to understand what ethics is, and that's been a theme in this series. And I think many people understand ethics in different ways. How I understand it is that every time you make a statement or a claim about what people should do, what they shouldn't do, what's right to do, what it's wrong to do, what's good, bad, all of these involve value judgments. They're not judgments that science alone, any science, can tell us the answers to. So all of us make ethical decisions every day when we decide whether to drive to work or ride, what sort of food to eat and so on. The problem with the real world is that these aren't identified as value judgments. They're seen as being judgments that science alone can answer. And probably one of the best examples I've seen of this actually comes, we didn't tee this up, but from Salk. So Salk developed the first polio vaccine. I used to be a doctor, so I know this story. It's one of my favourite examples of how value judgments slide under the radar. Salk provided a killed bacteria, a killed viral vaccine. So basically, the virus was dead when given to people. Sabin subsequently developed a live attenuated vaccine, where the vaccine was the virus was essentially disabled, not able to give rise to a full-blown infection, but the body developed immunity. And that was able to be given orally, and the Salk vaccine had to be injected. Now, the Salk vaccine had essentially no side effects. The Sabin vaccine had a very good side effect, and that is people tended to excrete it in their faeces, and it was spread to the unvaccinated community, and it provided a level of community immunity to people who weren't vaccinated. However, in a small number of individuals given the Sabin vaccine, they developed full-blown polio and ended up paralysed from Sabin. And that's a risk. You know, I don't know if you have children, but you've all probably been given Sabin, and your children have been given Sabin. There is a risk of developing polio from that. The decision was made by public health authorities on behalf of people, no consultation of individuals, you don't know this, that we will use Sabin vaccine. Salk is equally effective for the individual, but not as effective for the community. So the decision was made to sacrifice some individuals for the benefit of others without their knowledge. And that's exactly the sort of problem that you will see in geoengineering. There will always be winners and losers from climate change, from geoengineering, and effectively history has shown that governments make paternalistic decisions. They decide, as the BSE scandal here showed, they will decide what is safe, what people should know, and how they should. And of course, one of the great challenges today is to understand how people should be involved as autonomous agents in these sorts of decisions that affect their lives. So I think it's going to be a great challenge to geoengineering, and Steve and I have discussed this a lot, on how you could involve people in these sorts of decisions. And I wanted to make one point about analytic philosophy. Many of the decisions we make are based on ethical distinctions and principles that we don't realise, and one of them is this so-called intention-foresight distinction. So this was developed many years ago, I think originally by the Catholic Church, to justify, well, not primarily to justify, but in order, in some cases, to justify cases of abortion that are forbidden by the Catholic Church. You had cases where women were going to die if a fetus wasn't removed. Now, of course, the Catholic Church opposed to killing the fetus, so they devised this process of crushing the fetus's skull called craniectomy so it could be removed. And this was said to be not killing the fetus intentionally. The death of the fetus was just a foreseeable effect of saving the woman's life. This distinction was used in the Second World War to justify strategic bombing, where it was foreseen that a number of innocent people would be killed, but to count against intentional terrorist bombing. So you couldn't intentionally kill 100 people to strike fear into the opposition, but you could kill 100 people when you were aiming at a munitions dump. The US Army still uses this distinction to justify the killing of people in drone attacks, when you know that you will kill a number of innocent people, but it's merely foreseen, it's not intended. Now, many people, myself included, believe this is a false distinction. And if you believe it's a false distinction, then what we are doing every day today is, as Steve alluded to, geoengineering the planet. We're putting out carbon dioxide with knowing that it will cause climate change, and even if we don't intend the bad effects, we foresee them. So the distinctions that we hold make a big difference to how you view these sorts of technologies. Another distinction that's commonly used in the enhancement debate is the difference between treatment and enhancement. Medical science says treatment is okay, enhancement is not okay. Now, if you apply these principles to geoengineering the planet, on one view, one form of geoengineering we're morally obliged to pursue, because removing carbon dioxide removal technologies are actually an example of treatment, not enhancement. They're actually treating the disease that we've caused. The only way to resist this claim is to say there is something better about prevention rather than cure. So the opposition to geoengineering is based on a value claim that prevention is always preferable to cure. Now that's open to discussion, contention, argument. So it's not clear that we shouldn't pursue these technologies, and there's still a lot of discussion to be had. But I'll close there and say that more than in any other debate, the geoengineering debate shows the importance of value judgments, of identifying those, looking at the premises of the other side and looking at what they actually entail. So let me, I will make one more claim, one more thing about Collingridge. Steve and I have worked together a number of years. I've learned to love this guy, Collingridge. And actually it highlights a very important point that people make about ethics. People say ethics is relative. They say, I hear this all the time, you can't have a universal ethics. It's got to be relative to culture, and what was good for the Victorians wasn't good for us. This is totally mistaken. Totally mistaken. What they actually have in mind is a point I think that Collingridge was making here, is that every decision about what you should do has to be context specific. Okay? Even if you've got universal principles, you have to know what the facts are at the time that are relevant to that situation. You can't make a claim that freedom is always the ultimate value. There will be circumstances of emergency where freedom has to be given up. So when people say ethics is relative, what I think they really mean is it has to be context specific. So what decision we make about geoengineering will have to be context specific to, as Steve has said, to the technology at the time, the problems at the time, the costs and benefits at the time. But that's a basic principle that applies to every single ethical decision that you make. I can't tell you what the right thing to do is in any circumstance. In every circumstance, I have to know what the particular circumstances are. So when you're asked to make an ethical decision, you have to know what the facts are of that particular circumstance. So I think he was onto something very important. So we found an area of common ground. Let me open it up to questions.